Hello and welcome to my channel. So today we are going to talk about limits of rational functions. So what are those functions? Those have rational functions. So let's begin with an example to better understand this. So let's say I have an example here, question number 1. So let's say I have a question. I have to find the limit of this function when x is approaching 2, and the question is x cube minus 4x square plus 4x in the numerator, and on the denominator we have x square minus 4. So as you can see, we can either take it as two functions, first one being this function and second one being this function, right? So this can be written as limit for both x approaches to x3 minus 4x square plus 4x, and then divide by another limit x approaches to x square minus 4. So in both the cases, let's say it is continuous at x equals 2, so let's just put values of 2 here. We get 2 cube, that is 8 minus 4, 4 16 plus 4 2s are 8 and 4 minus 4. So we are getting, this is 8 8 8, and we are getting 0 by 0. So that means there's some, so we have to expand those functions here. We should not get 0 by 0 form, and if we are getting something like this, 0 and 0 on the both on the numerator as well as on the denominator, we try to expand these functions and then apply limits. So let me show you how to do that. So we have first working on the numerator, we have x3 minus 4x square plus and so applying the limits here, x approaches 2, right? So here we were getting 0, sorry, it's minus here, so let me rewrite this equation. We have x3 minus 4x square plus 4x, right? And we need to expand this function. So remember, I said if you're getting 0 by 0 form, we try to cancel out the factors which are causing the limit to be of the form 0 by 0. So we're trying to expand this function. We can see that x is a common factor here, so let's write it as, so this equals x times x square minus 4x plus 4, right? So here we can see this is a quadratic equation here, and trying to expand it further, we can write it as, so keeping the x here and then a big bracket. So we do something that is called splitting the middle term. Splitting the middle term to try to find the common factors here. So this is the middle term here, and we try to split it. So I can write this as x square minus 2x minus 2x plus 4, right? This can be written as this. So as we can see that minus 2 and minus 2 will be minus 4, and the product of these two, like 2 minus 2 and minus 2, should be equal to this number. So this, we have a quadratic equation as ax square, sorry, ax square plus bx plus c, right? So when we split the middle term, the addition of those new two terms should be equal to b, and the product of those terms should be equal to c. So here we can see minus 2 and minus 2 is minus 4, and the product is 4. If we multiply, we get 4, right? So this is what we are getting to find the common factors here. So it will become as x, and finding the common terms, we can write it as x times x minus 2, right? See x square and then minus 2x, and for this one we can write it as minus 2x minus 2. So here we can see that x minus 2 is a common thing. So then moving on, we are getting as x times x minus 2 is a common factor, and again x minus 2, right? So let me show you how we got this. So x minus 2 and x minus 2 in the bracket. So all in all, this whole quadratic equation has been reduced to x minus 2 times x minus 2. So from the beginning of the question, this is the numerator part. Now the denominator part, we had x square plus 4, I believe. Let's check that. Yeah, x square minus 4. So we had x, this can be written as x square minus 2 square, right? So another mathematical property we have from algebra, we have if something is given as x square minus b square, it can be rewritten as a minus b times a plus b, right? So rewriting the denominator, we have rewriting the whole function, we have x into x minus 2 and x minus 2 x plus 2. So we can see here this is cancelling out, so we are left with x times x minus 2 and x plus 2. So applying the limits here, we have applying the limits, x approaches 2, right? So we can write it as 2 times 2 minus 2 is 0, right? So we have 2 times 0, but on the denominator we have 2 plus 2, that is 4. So the limit will be 0 by 4, which is equal to 0. So we are no longer getting this function as the limit as 0 by 0 either, rather we are getting it as 0. So this is the limit of the function. So moving on to another problem. To better understand this, we have question number 2. So let's solve this. We have to find the limit of this function when x is approaching 2, and the denominator we have x square minus 4, and on the numerator, and on the denominator we have x cube minus 4x square plus 4x. So we can write it as x square minus 2 square and x times x square minus 4x plus 4, right? From the given property from the previous question, we have a square minus b square equals a minus b times a plus b, right? So we can write this as x minus 2 in the numerator and x plus 2, and in the denominator we can expand. This is the same function we got in the previous question, so you can go back and check that out. So we can write it as x times x minus 2 x minus 2, right? So we are getting this x minus 2 is common, cancelling this out, so the whole function becomes x plus 2 by x times x minus 2. So let me rewrite this. We were getting x plus 2 and x times x minus 2, and we have to find the limit at x approaches 2, right? So just substituting the value in as 2, we are getting 4 in the numerator and 0 in the denominator. So this means so since we can no longer expand this function again, so this is the end, this is how far we can go. So this is the limit 4 by 0. That means this does not exist, it is undefined, and limit does not exist for this function. So in the coming video we'll be talking about more limits on rational functions as well as some properties. So see you next time. Bye bye.